Okay, so I hope you did what I told you to do, but if you didn't, it wouldn't be the first time that people wouldn't listen to me, so I'm okay with that. Not a big deal. But if you're here to check your answers, good for you. You did your homework a little bit, right? If you're here just to kind of hit play on the next video to see how these turn out, well, at least you're hitting the play button to watch the videos. So I'm okay with that as well. So let's name the following: A, B, C, D, E, F. Okay, so we're going to start with A first. A looks like a double bond and a triple bond both. So how do we name this? Well, we found the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. And this is a 7 carbon chain. So it is a hept. Yeah, it's a hept something, all right. Well, what is it going to be? I've got a double and a triple both. Well, we've seen this type of example before. We know it's a hepton, and we know there's an "-ine" involved as well. That's how we kind of list them in the name. So if I look at this molecule, it looks like if I number to the left and give this a carbon 1, this would be a 1, 2, 3, and a 4. 5, 6, 7. If I go from the right to the left, this is going to give me a 3, 4, 5, and a 6. 3 and 6, higher than 1 and 4, isn't it? I hope so. So this is going to force me number from left to right. And at carbon 1, this is where I see the double bond. So 1 hepton. And then at carbon number 4, I see the triple bond of YNE. There you go, folks. There's the IUPAC name for that molecule. Again, it's a set of rules. If you know how to play the game, then you should be pretty good at the game, as long as you keep the rules in place. Let's look at B. B is a molecule that has 2 double bonds, so I know that this is going to be a diene. So how do we name it? Well, we pick the longest carbon chain that has both of those in it, if that's how we're going to name it. So that goes straight across. Total number of carbons, 1, 2, 3, 4, 5, and 6. So this is going to be a hexane, but I'm going to erase the ANE, right? And we're going to put an ENE. It erased my whole thing. However, there's 2 of these, so it's not just going to be a hexene, it's going to be a hexadiene, because there's 2 of those double bonds. All right, well, we need to figure out the numbers that go with them. What are the numbers? If I number from left to right, I'll get a 1, 2, 3, 4, 5. If I go from right to left, I'm going to get a 1, 2, 3, and a 4. Folks, which was lower? I hope so. I hope you told me 1 and 4 is lower than 2 and 5. So because of that, we are forced to number this way. So 1, 2, 3, 4, 5, 6 from the right-hand side. So at carbon number 1, that's where my first double bond is at. And on carbon number 4, that's where my next one's going to be. It is a hexadiene. And on top of that, on carbon number 4, we also have a methyl group. So 4-methyl, 1,4-hexadiene. Now, let's look at 6, or C, sorry. How do we name this? Oh my gosh. We've got 3. We have 2 double bonds, and we have a triple bond. So I need to come up with a way that's the longest carbon chain first that includes as many of the functional groups that we need to include in the name. And there's a couple of options here for us. One option is to go straight across, right? If I go straight across, this will allow me to get 2 of the 3. And it's a pretty long carbon chain. 1, 2, 3, 4, 5, 6, 7, and 8, right? So that's one option for me to do. Another option, keep in mind 8, all right? Another option is for me to kind of circle up and through here and do this round. Well, I still get 2 of the 3, right? And if I look at the longest carbon chain, 1, 2, 3, 4, 5, and 6, it's a lower number. It's not the longest chain. And keep in mind that doubles and triple bonds are looked at as equals. So the other version is going to be preferred just because it's the longest carbon chain. It still has 2 of 3 of those functional groups. It's not the only option though, right? We could actually go around another way. We could circle up in through here and do this. All right, so this will give me 2 of the 3, so we're no better off there. And if I look at the longest carbons, 1, 2, 3, 4, 5, 6, and 7. So it looks like the first way that I did it gives me 2 of the 3. No other option gave me anything better. And it also gave me the longest carbon chain. So there's going to be the preferred parent chain according to the IUPAC name. So we called 8 carbons here. Those 8 carbons, that's going to be an oct. In that parent chain, there is a double bond, so there's an ene. And there is a triple bond, so there is an ine. I have to write down both. They are regarded as equal, so my job is just to try to get the lowest number possible here. If I number from the left, I don't hit it until the 3rd carbon in. If I number from the right, that's my very first one. So that's going to force me to go this way with the numbering. So there's 5, 6, 7, and 8. So on carbon number 1, that is my on group. That's the triple bond. On carbon number 5, this is my ene group. That's my double bond. Now the issue is, what do we call this? We have to name that something. Well, I know it's going to happen on carbon 5. All right, so 5 something. Now you could come through and you could say, oh, well, this looks like a 2 carbon chain, so eth. And you could look at it and say, well, it's a double bond, so it's ethen. Maybe E-T-H-E-N, right? Well, there is a way that you could name it that way. But I want you to go back and remember a common name that we associated with that group. Remember, at one point in time I said, if a carbon double bonded to a carbon is attached to a main chain, well, sometimes that will not be part of the main chain. And here's that example. And we have a common name that goes along with this carbon double bonded carbon. Do you remember what that was called? If you said vinyl, then you're right. This is 5 vinyl, 5 octan, 1 ine. It's not the only way that we can name it, but it's the easiest way that we can name it. And we can go through and name it more of an IUPAC as far as the carbon double bonded carbon goes, but this gives me a chance to go back and review again the term of vinyl and allyl. If this carbon, and in this case it was, a C double bond C onto a main chain, that was called the vinyl group. If we had a main chain and that carbon was attached on a carbon with a double bonded carbon, we called this the allyl group, A-L-L-Y-L. Folks, that was presented in a couple of lecture modules back. Just gives me another chance to review it again, and that's what I did. All right, so let's take a look at D. D, I have 2 groups. A triple bond and an OH. Which one gets high priority? Well, I hope you told me the OH group, because it does. Longest carbon chain. 1, 2, 3, 4. There's 4 of them there. This is a bute. Well, it is an yne, Y-N-E, and it's also an OH group, which is an OL for alcohol. I've got to put both of these in a name. So, butane, and all. OH gets priority. That's why we named it as an alcohol. That's why this carbon gets number 1. That's the lowest group number for that OH. And that forces at carbon 3, the triple bond, which is YN. And at carbon 1, that gives me the all. 3 butane, 1 all. There's the name of that structure. E. Oh my gosh. What did they do to me in E? Well, for part E, it's no different. Don't freak out about it. I have 3 double bonds. Not an issue. Longest carbon chain. Start there first. Hopefully you can count the number of carbons. Okay, 1, 2, 3, 4, 5, 6, 7. So this is a hept. Normally it would be a heptene with an E-N-E, but there's more than one. So sometimes when we saw that, we just added that little A in there so it doesn't look weird or sound weird when we say it. There's 3 of these double bonds, so this is a triene, heptatriene. Now I just got to figure out what numbers go where. If I number from the left or if I number from the right, I hope that you're going to tell me you number from the right-hand side, because this will give you the lower numbers that are possible for this. You can actually see that without even questioning it. The double bonds are closer to the right-hand side than they are on the left-hand side. So at carbon number 1, and then at carbon number 3, that's where my next double bond is at. And then at carbon number 5, that's where my next double bond is at, I'll have the ene groups. 1, 3, 5, heptatriene. And now for F. F again gives me a double bond and an OH. I know that the OH gets priority. I need to kind of figure out a way to get the longest chain possible that includes everything that I can possibly can, and that includes that double bond. So 1, 2, 3, 4, 5, and 6 in total. So this is a hex. There's a double bond there, so this is a hexane. And there's an OL for the alcohol. I'm going to name it as an alcohol. That gives the priority. That means that this has to be carbon number 1. There's carbon 2, 3, 4, 5, and 6. So at carbon 1, I have the OL. At carbon number 4, I have the double bond. And then at carbon 2 and at carbon 4, I have a methyl group on each. So 2, 4, di, methyl, 4, hexane, 1, all. What a mouthful. 2,4-dimethyl, 4-hexane, 1 all. Yeah, folks, that's what we say in a lab environment. If we have to order that, that's what we'll say when we have to order it. That's what we type into our databases in order to use these compounds. I know, it's a mess. It's ugly. Nobody said organic was pretty, though. I think my handwriting might be a little prettier than organic, and that's saying quite a bit. All right, so that's where I'm going to stop this video. We've done a few more examples. We're not done with nomenclature yet, though. There is one more topic that I want to talk about, and that's more of a common name system. I know we did a few of these examples, but I'm going to go back to these two. This vinyl and allyl, we're going to see this show up again, but this time triple bonds there instead of double bonds. So what do we call those? We can't call those vinyl and allyl. Those represent double bonds in those locations. So imagine photocopying this little piece right here and changing a double bond to a triple. What do they call those functional groups when they show up on a main parent chain? And that's what you'll see next.